Alright, pre-calc. So chapter 6 is our next chapter. That's going to be all about law of sines and cosines, and then also we're going to talk about how to find the area of an oblique triangle. This first video today is going to be all about law of sines, in particular case 1. So we're going to have 4 different cases. 2 of them deal with law of sines, and that'll be 2 videos. 1 or 2 of them also deal with cosines, and we'll put that in just 1 video. So to start us off, our law of sines occurs when we have a triangle like you see here with sides A, B, and C, and then angles alpha, beta, and this is called gamma. Now you may also see this labeled with a capital A capital B, and a capital C. One thing to keep in mind is that angle A or alpha is always across from side A, angle B or beta always across from side B, and angle C or gamma is always across from side C. Our law of sines, then, the actual law of sines, is going to say 3 ratios, and they're always going to be equal. Now at any given time, we're going to use 2 of the 3 to solve for an unknown. So what that means is if we are using these first two, we have to know 3 of these 4 unknowns in order to find the unknown. We can only have 1 variable at a time when we're solving for this. Our law of cosines, which really we're going to focus on a lot more in a couple of videos. Same triangle, same idea. We're going to have 3 different formulas here. Okay, so they really all say the same thing, they're just written in different ways. One thing you'll notice is that whatever the value or the side is that is on this left side, its corresponding angle is what we're taking the cosine of. And now one common mistake as we get so involved with doing law of sines is that we put a sine here instead of cosine. Make sure, remember, this is the law of cosines. It should be a cosine value here. And then you'll notice everything else. We've got 2 other sides, and really our other big problem here is pay attention to your order of operations. Those are the 2 big things with this law. Okay, so like I said, there's going to be 4 different cases. The first one we're going to look at today is when we have 1 side and 2 angles. So you see side angle angle or angle side angle. It doesn't matter where the side is. It can be included or not included. Case 2 is we have 2 sides and a non-included angle, so side-side angle, and this is something called the ambiguous case, meaning there could be 0, 1, or 2 triangles, and we'll talk next video about how to solve for that. Law of cosines is then the case 3 and 4, and that's when we have 2 sides and 1 included angle. So you notice it's case 3 and 4, or case 2 and 3 are similar, where they have 2 sides and 1 angle, but where the angle is what really matters. And then the final one, case 4, is when we just have all 3 sides. Okay, so case 1, like we said, is what today is going to be about. The location of the side we said is irrelevant. It doesn't matter whether it's in between the angles or not in between the angles. It can be included or non-included is what we say there. So we have an example here. Then this is going to be angle beta. We don't know gamma, we don't know C, we don't know side B, which means this must be A and this must be alpha. So we're going to plug this in, sine alpha over A. The only thing we can find to start off with is side B. So we're going to say sine of beta over B. And if I plug in the values that I have, sine of 40 over 4 equals sine of 60 over our unknown B. A common way to solve this is just do cross multiplication. If we did solve this, we'd end up with B equals 4 sine of 60 over the sine of 40 if we take the time and do that. And so that tells us that B is going to be equal to, and the other thing to keep in mind here is that you need to make sure your calculator is in degrees for this one. So we're going to say 4 sine of 60 divided by sine of 40, and that's going to give us 5.4. So we have 5.4 here. Okay, now to find gamma, well, we just need to remember that a triangle adds up to 180, and so then gamma we know is going to be 80 degrees, because if I take 180 minus 40 minus 60, and now I can do the same idea. I'm going to choose a different color here, so I'm going to say sine of 40 over A, so sine of alpha over A equals, and now I'm going to say sine of 80 for gamma over C. And if we do that and solve the same way, C is just going to be 4 sine of 80 over the sine of 40. And we can plug that in. Again, we need to really make sure that we are in radians. and we should get that C is 6.12. So we get 6.12, and that's how we solve the law of cosines, or I'm sorry, the law of sines when we have case 1, so two angles in one side. Another thing to keep in mind to quickly check your work here to make sure that everything makes sense is, remember we've talked about earlier in the year, the smallest angle always has to be opposite the small side. So 40 and 4 are the smallest, that makes sense. 60 and 5.4, 80 and 6.12. Everything adds up. The smallest angle across from the small side, largest angle across from the largest side, and then obviously the one in the middle should be in the middle value. Okay, another example here then. Let's see, so we know that we have C, we don't have B or A. We could find gamma first by saying 180 minus 15 minus 35, so that's going to give us 130 degrees here, and we have to do that first so that we have a whole ratio here. Now it doesn't matter whether we find A or B first, but I'm going to set up sine of 130 over 5 equals, and I'm just going to find A first, sine of 35 over A, and solve this. That tells me that A is going to be, I need to plug into my calculator for sine of 35 over sine of 130. And if I plug that in, I'm going to get that A is 3.7. I switch my color. I'm doing the exact same process then. I'm going to still say sine of 130 over 5, and now I'm going to change to beta, so sine of 15 over B. And solve that would tell me, multiply both sides by B, and then I'd have 5 sine of 15 over the sine of 130. And I know that B should be the smallest side here. So if I plug that in, 5 sine of 15 divided by sine of 130, I get 1.7. And that makes sense because now I have 1.7 and 3.7, smallest angle, opposite small side, middle opposite middle, and largest opposite largest. And that is it for our law of sines video. Really, we're just plugging in. No unit circle in this chapter, no real fraction work other than our ratios, but if we just remember, always multiply by whatever your denominator is, that's how you're going to solve your ratios. And you can think about cross multiplying as well. We'd add an extra step, but that's okay. And we'll see you next time.